The lathe is a machine tool used to work on pieces with cylindrical, conical, or spherical shapes by removing chips. Its main function is to rotate the workpiece while a cutting tool removes the excess material, giving it the desired shape. The lathe is made up of several essential parts. The bed is the base on which all the components of the lathe are mounted. It provides stability and precision during the machining process. The gearbox and clutch are also important. The gearbox allows the selection of different rotation speeds for the spindle, while the clutch connects or disconnects the spindle from the motor. On the bed, there are guides that direct the movement of the carriage, which slides along the guides to move the tool into the working position. At the opposite end of the spindle, there is the tailstock, which supports the other end of the workpiece during machining. The quill, a movable part of the tailstock, also helps to support the workpiece. The cross-slide moves perpendicularly to the lathe's axis to adjust the cutting depth. Another important part is the tool post, which holds the tool and allows it to be rotated to change the cutting angle. Other components of the lathe include the chuck, the lead screw, and the spindle. The chuck holds the workpiece firmly on the spindle to ensure stability during rotation. The lead screw allows the automatic movement of the carriage for threading operations. The spindle, which is the heart of the lathe, is the rotating part that holds and spins the workpiece. Many lathes also have a coolant tank, which collects the coolant used to cool the tool and improve the surface finish of the workpiece. The lathe works by rotating the workpiece fixed on the spindle while the tool moves linearly against it, removing chips and shaping the piece as needed. There are different types of lathes, each suitable for specific tasks. The most common is the parallel lathe, used for cylindrical, conical, and flat machining on single pieces or small series. The vertical lathe has a vertically positioned spindle and is ideal for heavy and large workpieces, such as flanges or gear wheels. The turret lathe is used for repetitive tasks and allows quick tool changes, making it suitable for series production. The automatic lathe performs repetitive operations without the need for an operator, which is particularly useful for mass production. Lastly, the CNC lathe, or computer numerical control, is managed by a computer, ensuring high precision and repeatability for complex machining. Turning operations mainly use single-point cutting tools, which have only one active cutting edge. These tools ensure precision and control over the chips being removed. When choosing the shape and position of the cutting tool, several factors must be considered, such as the type of machining and the material to be worked on. The tool must be correctly aligned with the axis of the lathe to avoid vibrations and achieve a uniform surface finish. Different types of tool materials are used depending on the work requirements. The most common are high-speed steel, or HSS, suitable for low-speed machining on soft materials like aluminum and brass. Tungsten carbide, used for high-speed machining on hard materials such as alloy steels and cast iron. Ceramics and CBN, or cubic boron nitride, ideal for finishing operations on very hard and abrasive materials. And polycrystalline diamond, or PCD, used for non-ferrous materials like aluminum, copper, and composite materials. Parts and characteristics of lathe tools. A lathe tool is made up of several parts, each with a specific function. The shank is the part clamped in the tool post. The face is the surface on which the chips slide off after being cut. The main cutting edge is the part that removes the chips from the workpiece. The tool also has a main flank and a secondary flank. The main flank is behind the main cutting edge and prevents friction with the workpiece. The secondary flank is behind the secondary cutting edge and helps the tool penetrate the material. The secondary cutting edge is used to finish the workpiece and improve the surface quality. Characteristic angles of lathe tools. When working with the lathe, it is important to understand the characteristic angles of the cutting tool. There are three main angles. Beta, known as the rake angle of the main cutting edge. It determines how the tool penetrates the workpiece. Alpha, or clearance angle, which prevents friction between the tool and the workpiece. And gamma, or inclination angle of the face, which helps in chip removal. These angles are crucial for ensuring efficient cutting and good surface quality. Definition of turning. Turning is a mechanical machining process for chip removal, where a workpiece fixed on the spindle rotates while the tool moves against it to shape it. This operation allows the production of cylindrical, conical, flat, or spherical surfaces with high precision. Main turning operations. Turning operations can be categorized based on the type of surface being worked on and the direction of feed movement. According to the type of surface, there are three main types of turning. First, external cylindrical turning, which is used to shape the outside of cylindrical or conical pieces. Second, internal cylindrical turning, which creates holes or bores inside cylindrical pieces. And third, facing, which produces flat surfaces and shoulders on cylindrical or conical workpieces. Based on the direction of feed, turning can be longitudinal or transverse. In longitudinal turning, the tool moves parallel to the axis of the workpiece, which is ideal for creating cylindrical surfaces. In transverse turning, the tool moves perpendicular to the axis of the workpiece, typically for producing flat surfaces.